let's pick up where we left off. And I was reviewing in my head the explanation I gave on the edges, and I didn't necessarily like it. So if I didn't like it and get it, perhaps you guys didn't get it either. But at the end of the day, this whole chapter, we start looking at network graphing, is about this concept called modularity maximization. So modularity maximization, I think that's probably even a quiz question that you guys have coming up here. But essentially what this does is if you have all these items in a cluster, if you have two nodes with a shared edge, you're going to get a 1. And if you incorrectly cluster something that has an edge that shouldn't be attached, you have a 0. As we look at this, we also have to account for items that just happen by chance. So that's kind of what this whole picture was here. Let me expand this out. This whole thing was about looking at if you have a correct connection, you get 1 point. But if you look at Ross and Rachel, just based on the number of edges, there's like a 0.3% chance you're going to get Ross-Rachel connections if you use this formula down here. So what we do is we say, hey, we're just going to subtract out that by chance from the 1. So if they're supposed to be connected, great, but there was like a 0.3% chance that if we just grabbed anything, it was going to be connected. So we take that out. So even though it's correct and we give it a 1, we subtract out the random probability. If Ross and Rachel should have been connected and they weren't, we give that a 0 because they should have been connected and they weren't. And if they're incorrectly connected, not only do we give them a 0, but we also have to take out that penalty for them as well. So those are going to be kind of our 3 different cases we have. We have a correct connection, and instead of getting 1, you give 1 minus the random probability. If there should be a connection and there wasn't, they're going to get a 0. If you incorrectly assign 2 people, then you're not only are you going to get a 0, but you're also going to get the penalty. So now what we're going to do is we're going to apply this to Excel, and when we do, we get this formula right here. So if you look at this, we're taking the R neighborhood of this of the value. So we look at the value. If it's a 1, then you're going to subtract out the probability, the random probability. If it was a 0 and they weren't there, you're going to subtract out the random probability. So this is going to be the formula that we use, and we're just going to copy this across and down. So what you're going to want to do is open up your spreadsheet here, and then down in B102, we're just going to sum up all those values. So we're going to grab sum of B2 to B101. Brian.
Our neighborhood.
All right, so you're going to go into B102, paste that, pull it across, and then you're going to go into CX2, and then autofill that down and just do a sum in cell CX102. So if we take a look at this formula in the B2 on scores, we're taking the R neighborhood adjust value. So we're going to take whether it's a 0 or 1, and then we're going to subtract out the R neighborhood CX2. That's that volume, that's that row at the top for like atoms, times the 1 down here at the bottom. So that's going to be 14 squared divided by the overall CX102. So we're going to do that for each one. We're going to take the score, and then we're basically just going to subtract out the random probabilities, what we're doing right here. So just like we did before with Ross and Rachel here, we said we want to account for the random probability. We're doing the same thing right now in our score sheet here across all the wine customers, except instead of 6 nodes and 10 edges, we have 100 nodes and 858 edges. So we definitely scaled out and up. Okay. So once you get this, you're just going to auto. So if you look at the references, as we go across, CX2 is going to do what? So if you see $CX2 as you go across, is CX2 going to change? So CX is not going to change, but what happens if we go up and down? CX will stay the same, but 2 will go to 3. Okay, so that's on the column, but let's look at the row here. So B102 becomes what if we drag it across? In this case, the B $102. So B102 becomes C102, but if you go up and down, that doesn't change. So by doing this, you're always going to get the column, the CX column, and then the 102 row is what this is going to do and lock in for us. Okay, so just so you guys know that. All right, so then autofill that across and autofill that down. I do love autofill. Okay, that, and then you can pull that guy down. Autofill is your buddy, isn't it? It's just insane. Okay, so it should kind of look something like that. All right, so how's everybody doing? Everybody's good? A lot of numbers, isn't it? So how many numbers is it? Well, it's 10,000, right? Because we had 100 going left and right. We had 100 going up and down. So 100 times 100, we just did 10,000 numbers that quick. It's just, I'm telling you, I don't know. So I'm meeting with the counselors next week. I do need your guys' help. How do I tell the what do I tell the customers is your guys' is what's your experience in this class? I mean, what do I tell them? Think about it. If you guys have ideas, let me know. But it's just like, it's the numbers we do in this class are just so insane. So just like before, when we did the big M for when we started doing our suppliers, we're going to do the same thing over here. I'm going to blow this up a little bit. So if we wanted to, if we didn't want to do linear programming, we could do the evolutionary, but instead we're going to do this approach called divisive clustering. So everybody remembers biology, you're just going to split cells. So we have one solution, and we're going to put those guys in one of two communities, community 0 or community 1. And then we're going to take those guys, we're going to further split them out. So we'll take the 2 and make it into 8. And then we'll take we'll take the 2 and make them into 4, and then we'll see where we're at, then we can take the 4 and go make it into 8. So that's what we're going to start doing here. But the way we do this is we can't use an if statement, because we can't say, hey, if something is in column 0, don't have them in column 1. The second we do an if, we go from a linear programming to a what? Evolutionary. Good. Okay. So what we can do, just like we did in the last chapter making the orange juice, is we can use the big M constraint. And if you look at this formula here, what we're essentially going to do is we're going to take the sum product of everything that's in column B2 to B101, and we're going to multiply that times B2 going to CW2. So remember, we can't multiply a row by a column, but we can only multiply columns by columns and rows by rows, right? So how can we take that row, that BW or B2 to CW02, and make that into a column? Transpose. Brian, you're all over this today, man. Good. Okay, so we have B2. So if we take that row now, then we transpose it. Now we're taking the column B, and then we're going to transpose the row 2, and now we're going to have 2 columns. Anytime we do that, we're going to have to go throw that into that array formula. So we have to hit Control-Shift-Enter. And if you look at this, what happens is if you look at this first formula, we're going to do that, but we have the second part that's called 1 minus B2. If something is in the first column, or I'm sorry, if somebody is in the first community, if you have 1 minus 1, that becomes what? 0. So now you're multiplying that n part of the statement by 0, and all you have left is this first one. So what we have to do is we have to look at this and we have to take one of those out based on this whole big M constraint. So if somebody's in community 1, then that first formula, you take out that bottom, that second part, and you're just left with this first part. And that's what we want. On the second one, what happens if a person is in community 0? Or I'm sorry, in community 1. You have, so it's either, so if they're in community 1, you're going to use that upper formula, and that's going to be the formula. But if they're in community 0, or actually, so if they're in community 1, you want to have the left-hand portion of the first formula come into play, and then you don't want to have the second one. You want to make this like this some big, huge, big M number. So on the second one, what happens if you have 1 minus this gobbledygook, and then you say plus B2, which is 1 times that sum. So that sum is going to be this big, huge thing. And what we're going to do is we're going to set a constraint so it has to be less than those numbers. So one of those numbers is going to be small, one of those numbers is going to be big, depending on the community. So if somebody's in community 0, what's that first formula look like? So you have 1 minus B2, and then that second half of the first formula is going to blow up. And then what happens in this formula if they're in community 2? We have 0 times that sum, so only this part comes into play. So what we want to do, this is kind of hard to see, if somebody is in community 1, we just want this to be in play right here. Because if they're in community 1, if you do 1 minus B2, that takes that whole second part out. And if you do on the second row, if they're in community 1, this number 1 times this sum is going to be this big, huge number. Okay? If somebody is community 0, what happens to this first formula? Well, you have this number plus 1 minus this overall huge number, so that takes essentially that out of play once you put the constraints on. On this one, if you do 0 times that sum, it takes that bottom part out. So you guys see that? So if somebody's in community 1, you want the first half, you want the left half of the first formula to be in play, and you want to take that whole second formula, you want to take that whole thing and make it this big, huge number. If somebody is in community 0, you want to have the first formula be like this big, huge number, and you only want to have the left portion of this guy in play. So that's essentially what we're doing here. So if we come in here, let's unhide split 1. Okay, and then what we're going to do is in D2, we're going to put those formulas in here. So in D2, now remember, because we're doing that transpose, after you paste this in here, you have to hit Control, Shift, and Enter to make that into an array formula. Then we can send that guy down. Okay, and then copy the second formula into E2. Oh, wait, don't do like I did, hit Control Shift Enter. So as they are, one of these is going to be big and one of these is going to be small, but as you start putting them into communities, you're going to see that this is going to go, these numbers are going to go up and down, and we're going to solve for these numbers, and what we're going to say is we're going to optimize that score to be minimum, and we're going to set those upper bounds to be our constraints is what we're going to do here. And then solver is going to go away and go do its thing. So what we want to do is we want to have in G2, now we want to get the sum of C2 to C101 divided by the overall number of all the nodes. Okay, and since we have 0 there, we're going to have 0 there. Okay. Yep.
Having trouble with that.
So make sure, yeah, so if you guys get So what we're going to do here is we're going to maximize our total score, but we're going to set these guys as constraints. And by doing that, these are going to be those big M numbers. So it's basically going to take one of those out or the other out. So let's open solver now. So if you go into data, and then solver, not open solver, but solver. We want to maximize G2. And then our decision variables, we're going to be B2101 to C2101. So we're going to do B2 all the way down. Oh, sorry. Don't do what I did. Make sure you move cells. So we want to maximize, and then cells we're going to change as B2 down to B101, comma, C2 to C101.
What if you group them both? Like you just grab the answer?
No, well, you don't want to do that whole range. You want to do it as two separate things. Yeah, you want to do them individually, because now we're looking at one's like a community and the other one's a score. If you did them, you'd make it all wonky. Yep. Okay, but good question. I was initially, when I looked at it, I'm like, why can't we group this? And I'm like, this kind of makes sense. Okay, now the other thing we want to do too is on these communities, we're just going to say this is either community 0 or 1. So we're going to make this binary. Okay, so we're going to set that into binary. So let's start adding some constraints. And then B2 to B101, we're going to say is binary. So you just click that center thing and hit bin. That means binary. And we're going to add another constraint. And we're going to say C2 to C101 is less than or equal to D2 to D101. Yeah, I keep not doing this. So C2, ugh. I'm being a bonehead today. All right, so let me add, and then we're going to say C2 to C101 is less than or equal to E2 to E101. And just so you know, you can either start from the bottom or the top when you're doing your constraints. It figures it out. Okay, and then we're going to click on OK, and then we want to say the make unconstrained values non-negative. So we're going to make sure that's checked. We also want to now use simplex LP in here because we made it linear by doing this big M constraints. And then since we have over 200 variables, we're going to have to open up open solver now. So we'll close for now. And then it's much easier doing a constraints in the Excel side and bringing it over into the open solver side. So let's go into open solver. Yep, I didn't want to do that. So go into open solver, and then you're going to set the open solver model options. my guy's jammed now. So yeah, so go in and 200. So yeah, so you're going into model options, max time 120 seconds, and now you can kind of just see that thing cooking down at the bottom. If you look, it's kind of faint, but you see open solver, solving model, 200 variables, 100 integer variables, and you just see it like just cranking through.
All right. What's the customer score variables constraint under constraints?
So yeah, so that's basically what we just did right there. So
Okay.
so the C2 to C101, what we basically said is, hey, have this customer course. That's basically verbally what we did above.
Okay.
Yeah. Yep. So we set a customer score variable, so it's gonna be less than that upper boundary. So depending on if there's 0 or 1, it's gonna take 1 out of place. If it's 1, it's gonna take if it's gonna be, and you'll see once it ends, you'll see all these guys shift around, but you'll see that this score is gonna be right next to one of these two values, depending on if they're community 1 or community 0. So this is just going to an optimizing all that and say, are you community 0 or are you community 1? And then community 0, community 1. And it's gonna maximize that value out. But like I said, the math this thing is doing is just absolutely crazy, insane when you look at this stuff. So you'll see mine's like at 93 seconds. You guys is probably going to be finishing up soon. So yeah, so we should all get around 464,397. How are you doing, Brian? You got that? All right, cool. And yours is almost done, Alex? Cooking? All right, cool. All right, so we'll let yours cook and we're going to keep going. Because the next couple of slides, we're not going to. So if we look at this, at split 1, we can see that this assigned the different communities in here. So we've basically taken those numbers now and we split them into 2 communities because they're either in community 1 or community 0. And what we want to do now is we want to further split these guys into 2 more. So it's kind of like right now we have, if you look at a person like Adams, they're in either 0 or 1. And then what we can do is we can actually split these, and then this can be 0 or 1, and then this can be 0 or 1. So then we're going to have like 4 communities, and we're going to keep doing this until our score goes up. So every time we do this, as we keep going, our score is going to start getting better and better as we do this. So we're going to now take this, and then we're going to do the split 2. So so we're going to copy split 1 and rename that split 2. How are you doing, Alex? Are you good? Almost done. Okay, so what we're going to do now is just take split 1. So you guys are going to right click split 1. Or not. All right. So click, you might have to click on the Excel and then click that little box that says okay. So once you do that, we're going to right click split 1. We're going to move or make a copy, move it to the end, create a copy. We're going to call this split 2 now. Split 2. Okay, so now we're going to insert a new column C. So click on C, we're going to right click and insert. And then we're going to copy, we're going to call this last run. And then you're going to copy and paste the values here from community. And then paste the values over into column C. So what we're doing here, let me pull this over, make it big. So it's the same formula we had before, sum product plus 1 minus that. The only thing this time is that we said if C2 to C1 equals C2, then you're going to call it, we're going to say it's 1. Otherwise, you're going to say it's 0, and you're doing it on both of these. By doing that, you can now say, hey, if this is equal to the other one, you can now basically split these into 2 groups. So we have 2 communities right now. We have community 0 and community 1. What we want to do is we want to further take 0 and say a person's either in 0 or 1. But this would be essentially somebody that's in 0, 0 or 0, 1 or 1, 0 or 1, 1. So by doing that, binarily, we create 4 different groups. So everybody see that? So even these 0s and 1s down here, you have to say that this is really 0, 0 and 0, 1 and 1, 0 and 1, 1. So if you count binarily, so 0, 0 is 0, 0, 1 is 1, 1, 0 is 2, and 1, 1 is 3. So that's essentially what we're going to come out with. And then there's this really cool function that'll take these numbers and generate the communities for us. It's just, it's craziness, isn't it, guys? This is like totally like nuts, but I love it. I mean, you guys, I'm telling you, you guys, like, compared to other people, you're like leaps and bounds. So let's go update E1 and F, or E2 and F2 with these 2 new formulas. So it's basically just using an if in there to further split these communities 1 more level. So we're going to copy this into E2. So again, this is going to be that whole transpose thing. So make sure you're doing Control, Shift, and Enter to get to the array formula. And then you can send that down. And then you're going to copy that formula into F2. And you're going to send that guy down. All right, how's everybody doing? Good? This is just like totally radical. I get the biggest kick every time I'm doing these exercises. Like, wow, it's like, man, it's like if I knew this, like if I knew this in college, and kind of like, although this is since when I went to college like 20 years ago, we didn't have this, I mean, the whole Moore's law thing. Like 25 years ago, we never had computers that could do this. This would be like a supercomputer at Utah. All right, so everybody has this now. So let's go back in and let's go into, so we're gonna have to use OpenSolver again. So let's go back into Model, Options, and let's validate that it says make unconstrained variables non-negative, and it still says 120. If that's the case, click on OK, and then go hit Solve, and let's let it cook through for another couple minutes. And then let's see what we had before, because I think we all had 0.464397. So if the number goes up this next time when we're doing a score, it means our model got that much better. So you're basically going to keep splitting this out until the score doesn't get any higher. So that's kind of like what we're up to right now. So in the sake of time, spoiler alert, if we did split 3 into this one more time, we basically have to do this if. One more time, it would be if times an if. And it gets to be really nasty. So I'm going to spare you guys that. The book did it, I think, but I'm going to spare you guys that. If you do split 3, it doesn't really move the needle. So based on this model, since the model didn't move, it's going to say, hey, this is going to be best if you do 4 communities here. So what's the disadvantage of doing this way? Can anybody think of a disadvantage doing it this way? This divisive clustering? What do you guys think? So we jump from 2 to 4. If we did a split 3, how many numbers are we going to have? If we double this number? 8. So if the score doesn't move, that means that, well, you know, we went from 4 to 8, but maybe like 5, 6, or 7 would have been a better number. But because we did it this way and we did the simplex method, we couldn't look at 5, 6, or 7. We only could look at 4. The next value we can look at is 8. So that's one disadvantage of this divisive clustering, is you have to do it in multiples of 2. So it could be that later on we see a different method where we're somewhere between 4 and we're somewhere in between 8. Well, evolutionary, that would still be the same thing, except their numbers would be less consistent. But I'm going to show you guys will see in a second. I'm building up, but you'll love this when we get to this one spot. So spoiler alert, there's nothing here. So now what we want to do is we want to take these different numbers and we want to go take this and take those binary numbers and make them into decimal numbers. So if we go to slide 28, this is exactly what I did on the board here, is that if we said somebody's in 0, 0, that's community 1, 0, 1, that's going to be in community 1, or 0, 0 is community 0, 0, 1 is going to be community 1, 1, 0 is going to be in community 2, and 1, 1 will be in community 3. So let's right click and unhide our community sheet. Okay, and what we're going to do is we're going to copy and paste split 2, BC2, or B2 to C101. So you're just going to grab these values right here. B2 down to C101, and you're going to copy, and you're going to paste the values in. And then this is going to show what we did in split 1. This is going to show what we did in split 2. And then there's this really cool formula in here that's called bin to des. And what this does is it'll take these binary decimals, or it'll take the binary numbers and convert that into decimal by concatenating B2, adding B2 and C2 together, which is pretty cool stuff. So do that and then run that down, and you're going to start seeing a person's going to be in community 0, 1, or 2, or 3. So grab this formula here. And then send that down. Okay, now you guys go. So we took these guys, and now we have them split out based on these numbers into one of 4 communities. Community 0, 1, 2, or 3. Pretty craziness. Pretty craziness. All right. Everybody's doing good? All right, so now let's go unhide the top deals by cluster sheet. This is going to look all familiar to us. All right, and then now we're just going to do that same formula that we did before when we did the wine solution. The sum product of communities equals the top clusters. So basically what we're doing here is we're looking at if the community on, if the community for D2 to D101 equals the top deals by cluster, H1 through K1, then you're basically going to transpose and add up all those numbers from the matrix. That's going to be that first sheet that we started with right here, and that's going to give us our cluster numbers. So this is the same exact sheet we used way back when on chapter 3, except we used a completely different model this time. This time we used divisive clustering through network graphs versus the k-means clustering and k-medians clustering. So a whole different new model, a whole different new way to look at things with similar results here. So let's grab this formula here in H2. And again, because we're doing that whole transpose thing, they're going to have to do, if you go into top deals by cluster, you have to do the Control-Shift-Enter. Okay, and then now we could just drag this over. And we can drag it down. And then with all these guys highlighted, just go back into home and do conditional formatting. And then do color scales. Pick whatever color scale you like. I like that green-white color scale. Okay, anybody for a sticker? Anybody guess what we're gonna do next? What do you guys think? I'm sorry? Sort them, who said that? Anthony, good job. Okay, so this is just like the test, right? So this is the same thing. So let's go grab all those columns in there. Let's do custom sort and filter, and let's lather, rinse, repeat, just like what we've done before. So go in and grab A to K. And we can go into the custom sort. And let's sort by, after past peak, you see the 0. And just do, we want to order from largest to smallest. Okay. And what do you guys think? What do you have for a cluster in this first one?
Minimum quantity.
Minimum quantity. Oh my gosh. But again, we get the same results we had before, but a completely different model, which is pretty insane. All right. So what do you guys get for? What do you guys get for column 2 here? Why did my filtering fell off? For filter. Okay, so let's go and filter out smallest to largest on column I. Okay, what do you guys have here? What do you guys get in column I? You see anything that's DNR? Pretty crazy stuff. All right, let's go into column J. Okay, what are you guys getting here?
Minimum quantity.
So minimum quantity, little French, so kind of, I get the same thing. But if you look on this one, and this one's kind of tricky, but if you see that first top number, that one's like a 15 compared to 7. So if these numbers are similar, like if you look at like column number H here, and you do largest to smallest, these are all kind of relatively the same strengths, 11, 11, 10, 9, and then it drops down to 3. So I'd say those first 4 rows, that's what's kind of driving that value right there. Okay, so if we go to column J, what do you guys think is driving that one? The 15. So there's like a huge gap between like 15 down. So this one, probably it's the Asfumanti is what's really driving this one. So you guys see, does that make sense? Where you see, so if this was like, 15, 14, 14, 13, yeah, the second and below rows would kind of be in play. But for this one, since you have 15 and the next one 7, it's the Asfumanti that's really driving that one. All right, and then let's go look at the K. Let's see what we come up with here. Okay, so what do we have here? Champagne. Actually, this is going to be maximum quantity. Okay, what about the origins? So it's kind of like French champagne here. Okay. You guys see that? Pretty cool stuff. So the next couple of steps, don't hate me, don't be haters. This is kind of fun, these next couple of steps. So we did that. So basically your homework, just do like you did before. So quiz 7, question 11, go through and do what we just did here in class. All right, so there and back again. Let's go back into GEPI. So what we're going to do is let's go in and we're going to save the our neighborhood adjacency sheet as a CSV file. So go into our neighborhood. So click on that tab. And then go into File, Save As, Browse. Then you can just save that to the desktop. But instead of Workbook, you're going to go in and you're going to say CSV file. So it's probably maybe like 12 or 15 down. But actually, before you do this, wait, cancel. Don't do this yet. The first thing you're going to do is save this sheet right here. So save this sheet, the wine network. Now go back in and save this as a CSV file. Save as, browse, desktop, and then call this guy CSV. And if you want to, just call this Gephi import. And you're going to say, hey, you can't do multiple sheets. You're going to click on OK, and it's going to give you another warning saying, hey, do you really want to do this as a CSV file? And you're going to say yes. All right, so now the cool thing with this new version of Gephi is that you don't have to do that whole change the commas around with the semicolon. So I forgot to clean up this slide here. So let's open up and launch Gephi. So if you go to the desktop, launch Gephi. So this is like so cool what we're getting ready to do. It'll just blow your brains. All right, so once you get to this welcome screen, you're going to open up a graph file once it allows you to. And then now go into desktop and then go into that Gephi import file you just created. Okay, it's going to say comma, it's going to say matrix, yep. And you're going to go next. You're going to go finish. And then remember, so you're going to get two warnings right here. The first warning is going to say, hey, record 1, it's missing that label at column 101. That's okay, that was a total one, so we want to dump that out anyways. And it's going to say, hey, at the start of the line 102, that's where we did the sums. It doesn't have an opening marker. We're going to throw that one out too, and that's good. You didn't want to bring those in anyways. Graph type, mixed, or what do you guys think? Do you remember what we wanted to have here? So if you open that checkbox down, we wanted to have mixed, directed, or undirected. Undirected, right? So we want to do undirected. So do undirected, and you're going to click on OK. Okay? So here's our graph right here. It's kind of a mess. So we're doing just what we did before. Now, the only issue with this new Gephi is because Parker had 0. If you look at Parker, Parker has 0, but he's going to be missing in here because Gephi doesn't bring it in. So go into the Data Laboratory tab right now. So you'll see Data Laboratory tab at the top. And then let's go create a node for Parker. So up here at the top, you're gonna click Add Node. And on that label, you're going to call it Parker. And you can click on OK. Okay, and then now if we go back into Overview, you should see 100 and 429 edges.
You refresh something?
If you just go from Data Laboratory into Overview in the upper right-hand corner, you should see 100, 429. You got that? All right, so now let's go back in and let's do our layout again. So under this layout section here, just go click on the Frugermeyer Reinhold thing and hit run. Or actually, no, I'm sorry. Do that force atlas too. Okay. So if you look at that, you're going to see kind of like this clump, but then way out there, guess who that is? That's Parker. He's not loved. So go grab Parker and go rein him back in. So just go left click Parker here. And you can kind of drag him down into the fold right here. Now you can start expanding this out a little bit, and then left click and drag it over, make it a little bit bigger. And then now you could go throw some labels on there, and you can adjust your label size down. Okay. So the next thing we want to do, this is gonna like blow your guys' minds away.
I threw in Parker, but he's not showing up.
No, he's like way out there. So if you expand out.
Oh yeah.
No, if you hit Force Atlas, and let that run for like 1.3 seconds, Parker's like 3 states away. So just kind of herd him back in there. All right, so this is like the coolest thing in the world now. Go into statistics. So over here on this right-hand side, go into statistics, okay? And you're gonna see this little modularity button over there. See that modularity button? Go click run. So you can uncheck use weights and click on OK. So if you look at this, guess what this just did for us? So this just came up with 5 clusters just like that. So all the stuff we've been doing in Excel, this just did in that 1 second. That's why I said, don't hate me. So if you only have 4 clusters, if yours only has like 0 to 4, hit run one more time. So I want to have it so you get up to 5 clusters or 6 clusters. 6 clusters.
So cluster 0 has 28 nodes. Cluster 1 has 15 nodes.
Yeah, exactly. So yeah, so everybody has. So all of ours are going to be different. So all yours will be different. So yeah, mine has 28. So it should be kind of somewhere in here. So now, guess what we can go do? So we have this. So yeah, you might be thinking I'm evil since we're able to solve the clusters in a few seconds with GetFi. So yes. So now if we go look at this guy, so here's the cool thing, is if we go back into GetFi now, go into up here under nodes and go into ranking, and then choose an attribute up here and do modularity class, and come up here and click this little color palette thing right here, and go to default and just pick your favorite color scheme. Now go click apply. Now you can see all 6 clusters in color. Craziness, isn't it? So, so you have like the 2 big major clumps. How do you, okay, so let's see. So let's go and force that one. Okay, so let's see. Random modularity. Okay, so you got that. And then let's do nodes. There, here, and then I'm going to apply. Now let's drop it. Okay. I'm going to make that a little bit bigger. All right.
Is there a way to like increase the space so we can see top separately, but they're still in the pumps?
Yeah, so you just hover over them.
Okay.
So now, so actually rerun yours again. Run yours one more time. Just hit it. Yeah, run that. And click that. And then run it one more time. Run it one more time. There you go. Now hit close. Now go in and hit one, two, three, four, five. So go hit apply now. Hit apply. There you go. Okay. All right, cool. So now, so this is what's really cool about this now. Before we kind of had like, if you looked at this, we had what, if you hover over your mouse, watch this. If you hover over your mouse, like in a certain clump, you'll just kind of like drown out the other ones. So like in this blue one, you can see all the people here. So what this did is, remember before when we looked at this, like maybe like 20 slides ago, we had those like two major clusters on each end, and we had Parker by himself. But in the center here, in the center, we kind of had that glob mix, and we didn't really know what was going on in there. Well, now we kind of know that this is like three different clusters. We have the light blue ones, and then we have like the green ones, and now we have like these light orange ones. So now we're able to see those three clusters in the center. Now we could visually see these guys. So this is what's cool about network graphing, is that now we can actually show somebody, here's your clumps right here. But what are these clumps? We don't know what they are. So what we want to do now is we're going to export this out and import it back into Excel, and then now we're going to be able to do the same thing we just did. Craziness. Okay, so let's go into, so we're going to go into the data laboratory now. And then here you're going to be able to click on this export table. And then export this to the desktop, and you can just call this like GEFI output. GEFI output. Oh, wait a second. Do that, export the table. Let me see. Oh, and when you do this, click on options actually. And then just have the ID, or just, yeah, have the ID and have the interval and modularity class, and click on OK. And now save this guy. And it'll say right over top of it. All right. So now let's go create a new worksheet called GEFI's Community. So open back up. So go back onto the desktop and open up your Wine Network. And then click a new sheet here and call this Communities GEFI. All right, and then now you're going to open up your GEFI export. So go back onto desktop, GEFI output or export or whatever you call it. And now just go grab these guys. Grab these guys and then go paste it into your community's GEFI. Where is that? Let's see. So come into, I opened up the wrong file. My network. Yeah, all right. Hold on, let's see. Save. All right, so I'm gonna, oh, the sheet one, all right, communities GEFI. And then up here in A1, just go paste that down in there. And if you guys come all the way down at the bottom, you should see 101. You're going to see 05. Guess who that is? That's Parker. So let's go put Parker in there. And then now come over here, and you're going to have to sort these guys out. So sort by column A.
I don't even know